Introducing MotorMS. MotorMS is an application for motor design improvement by new material selection. Who is it intended for? It is for manufacturers who have existing lineups of motors in a manufacturer catalog, and for those manufacturers who already have manufacturing tools and assembly processes that are well established. So for these manufacturers, are there any possibility of motor lineup improvement to improve, for example, electromechanical performance, thermal performance, mechanical strength and integrity, and weight or cost of raw material for their existing lineups? And of course, the next question would be, if there is any possibility, what would be the easiest way to improve the existing motor lineup without changing the existing topology or design of the machine, and without changing, of course, the most expensive one, that will be the manufacturing facilities? Are there any potential solution? Yes, there is, which is material change for components, which means we could change the material for each component using another material that could probably increase the performance of the machine for several different criteria. Material change for motor components. So how do we select the best choice of materials for multiple components to improve multiple criteria, as mentioned just now, such as electromechanical performance, thermal performance, and others? There are many components, and how do we change the materials for different criteria for each components and parts? So the solution is what we call as VIKOR method. So what is VIKOR method? VIKOR method is a multi-criteria decision-making method, which is also called as MCDM. So it is used to solve discrete decision problem with non-commensurable and conflicting criteria that produce a solution which is what we call as a compromise solution. It is a solution that is feasible, which is the closest to the ideal, and compromise means an agreement established by mutual concessions. So these concessions means basically the concessions between multiple criteria of different parts of the existing motors. And how does it help us? It basically produces in the output a ranking of selection of combination of material, and this ranking, of course, focuses on selecting from the set of alternatives that we have given to the VIKOR method or VIKOR algorithm in input. Let's have a look at the algorithm of VIKOR method very quickly and very briefly. So what we need to do first in the background of the algorithm is to create a list of alternatives of material for different components of the motors, and then secondly to create what we call as decision matrix, and from different calculation in step 3, 4 and 5, we will calculate what we call as Ri, the regret value, Si, the utility value, and Qi, which is the ranking, which is the output that will give us the combination of material. It can be summarized with this methodology or flowchart that we have on the right. There are many references that we can find in the literature that is using VIKOR method, but for different other applications, such as the choice of material or components, or even manufacturers and suppliers for different manufacturing and engineering problems. Now let's have a look at the most important part, which is the application that we have developed, MotorMS. We will start with the interface, the first page, which is the welcome screen. You will be welcomed by the page of instruction, where there is a brief explanation of what MotorMS is all about, and there is of course a list of things that you need to go through, the steps that you need to follow in order to use the application properly. The next one, which is the next step, is of course the component selection. So for a selected motors, you could choose different components that we want to improve by selecting from the drop-down menu. We can choose up to 5 components. So for example here, for a brush DC motor, we can choose multiple components ranging from brush, bearing, the motor core, the state rotor core, and even the winding insulation. The next step would be to select the material option that is to be chosen to replace the existing material inside the motor. So for that, we have the next tab, which is the material option tab. So we can see here, basically, the component that was selected in the previous tab is displayed. So there are the 5 components that we have selected in the previous tabs, which are the casing, brush, permanent magnet, core, and winding insulation. And here what we are doing is basically we have to select the material option that we are interested in comparing. So for example, here we are going to select all of the material to see what the ranking would be. And the next step is the material criteria selection. Once we have selected the material that we want to compare, of course we have to select the criteria that we are interested in to optimize. So for each component that we have selected, from casing to winding insulation, we can select different criteria that we want to improve that are important for us in the new material selection. So for each component, we could have different types of criteria depending on the parts. So for example, a casing would need to be strong mechanically. Otherwise, it is not important for the casing to be a very good current carrying capacity, such as the brush. And of course, as you can see here, for different parts, there will be variation in terms of the criteria that we can select. The next tab, once we did the criteria selection, of course, the tools MotorMS, the application, will calculate and will give us the ranking for each part. So what we are looking at now is basically the ranking of the material that have been selected, and the ranking have been done depending on basically the criteria of selection that we've made in the previous step. So for casing, brush, magnet, core, rotor core, insulation, we have, for example, in ranking 1, we should choose aluminium, natural graphite, ceramic, and carbon steel 52, and air for the component that we have selected. So what are the originality of this application MotorMS? The first one is the application is very easy and light to deploy. It is an application that count up to 1.6 megabyte in terms of size, so it's very light. It can be installed as a MATLAB application, as we are looking at the clip over here, and it can be downloaded from our website, the developer website. It is now freely available as in a version beta 1.0, and of course in the website as well we provide the material library and the characteristic of each material that we have provided in the application, and it can be looked at as a reference for the users. As for status of innovation, now the application is considered to be in stage 4 of technology readiness level. It is a prototype that has been used by our lab members, and it has been developed in collaboration with 2 postgraduate students who have from the development of applications, and supporting the development of the application has produced multiple research papers that are now in reviews. And in terms of potential users, we may have, of course, the most interested party would be the motor manufacturers. It could also be used for the purpose of education and trainings to let the students and the researchers to be aware about the importance of selecting a proper material and the consequence on the performance of different part of the machine. And finally, of course, for the researchers, for them to use to select new materials, and of course they might be able to validate the choice experimentally later in their research. That's all. Thank you from our team from MotorMS.